As we continue to talk about simulations and predicting the future, it's going to be useful to have a shared language for what all of the different numbers are in a simulation, what do the different values represent, and they actually fall into a few different categories. So the primary things we've talked about was height that changed over time, things like velocity that impact the height, things like delta H and delta V that are changes in any one instant of time, and things like the acceleration. So these different columns, different variables, different numbers in here actually have different roles in this particular model. So the variables, the things that you can actually measure, these are things that are observable. And the ones in this case are the height of the thing above the ground, and in fact the velocity. So these are things that are a function of time, and that they are things that we keep track of in each time step as the simulation or as the model proceeds through each different sequential second of time. The second itself is a constant. It's a feature of the way that the model was built. So the delta t in this is 1 second. And that's something that actually becomes difficult to change once the model is built. The model is built with a certain time step in mind. That's a feature of the model itself. It looks in this case like the acceleration is also a constant, but it plays a different role. The constant A is a parameter because it's something that you could change once the simulation once the model is constructed to give you a different output. So you would change a parameter to model a different system. If I was to go in here and just change this, I'll put it in sparkly multicolored, change this and make it -6. So we'd be working on a different planet where the acceleration is different. Changing that one value changes every single other value in the whole table because it changes this value to -6, it changes this value to -6, it changes that value to -6, it changes this value to -6. It changes this value to -12. It changes this value from 600 to 594. This one would be 5, whatever it is. And so you would be looking at changes that would be different, but the only thing you need to do to make that happen is by changing that one parameter, which changes the entire behavior of the system. The other thing that's in here is actually the value of the height at time 0. So we can call that either input or an initial value. So h at time 0 plays a similar role to a parameter, but it describes the initial state of the system. So it's the starting value for one of the variables as opposed to a parameter that affects how the variables themselves change over time.